apart from in kindergarten, every year starts with place value and then it continues all year. And again, I'll show you here. We've got place value, term 1, place value, term 2, place value, place value. We're focusing on it at least half an hour, sometimes an hour and a half, sometimes an hour a week. And that's additive place value. So this standard and non-standard. So for example, if I've got 63, standard place value means I'm describing it in a way that can be recorded in a place value chart. So 6 10s and 3 1s can be recorded in a place value chart that way. Non-standard means we're still describing it using 10s and 1s, but not in a way that we can record it in a place value chart. So for example, if I've got 63, it could be 5 10s and 13 1s. That can't be recorded that way in a place value chart because you're not allowed to put 13 in one column. Or it could be 2 10s and 43 1s. And then obviously you can do it with higher and higher and higher numbers. You can do it with decimal. So if it was 6.3, 6 1s and 3 tenths, 2 1s and 43 tenths. So it's exactly the same concept. That's additive because we're adding the 10s and the 1s or the 1s and the tenths together to make the number. Because the investigation and the explicit teaching is the same, regardless of whether we're doing a teen number or a number with decimals, the kids can see, oh, that's just the same as that. It's exactly the same concept. I'm just doing it with a larger number or a more complex number. Don't be worried if in the beginning of the year you've got to teach much lower levels, because those outcomes are outcomes for the end of the year. In every single year, we are teaching place value all year. We might be introducing the concept in term 1, but then we're going to keep adding the anchor charts throughout the whole year, so the kids are just working their way through place value all year. With addition and subtraction though, because your year 4 haven't come through necessarily with the deep understanding of adding single digit and so on, they're going to have to drop back to the year 1 level, which is bridging 10. Because if they can't bridge 10, they're not going to be able to bridge any other place value. Down here it's got differentiating up and down, adding and subtracting single digit numbers, bridging 10 is one way that you can differentiate down. In the very first lesson with year 4, the same as I did in year 3, I would put up adding and subtracting, counting by ones on a number line, adding and subtracting, bridging 10, and then I would say, show me which one you can do. And if you can already do the counting by ones, try the bridging 10. See if you can work that out, particularly if they've never seen it before. From that, you've now found out, okay, what kind of place value understanding is in the class already. Did any of them work out how to bridge 10 if they haven't seen it before? Or if they have seen it before, did they somehow try to show it to me? So that will give you an idea of which kids are still counting by ones. That's fine. If they've got counting by ones, their next level, which is their next level of productive struggle, is bridging 10. So basically, year 2, 3 and 4 might look very similar initially, but you will find that your year 3 and 4 kids, a lot of them will move faster. This is where you can make a decision with your year 4 kids. The kids who are just stuck, still can't bridge 10, still can't bridge 10, still can't bridge 10. You then use your teacher professional judgment of, I'm just going to teach these kids the algorithm, because the algorithm you can do counting by ones. So it's not their fault that they didn't get this. If they'd got this in year 1 and then in year 2, they would already have it. And you might only have one, or you might have half your class. And again, it's teacher professional judgment. Okay, let's look at their books. Let's look at what they're doing. The kids who are really getting the algorithm for addition and subtraction, I would get them to use compensation. So compensation with 2-digit numbers, compensation with 3-digit numbers, and so on, because that's what they're going to use as an adult. No child is going to use an algorithm as an adult. Hardly anyone does right now. Something like less than 10% of adults ever use an algorithm now. And that was research that came out about 20 years ago. And I think that 10% that does is probably teachers. And the algorithm's not mandatory, because if you've got deep understanding, we call it number sense, deep understanding of the size of the numbers and how big a number you're likely to get if you add it or subtract it, and you've got mental strategies, and the mental strategies include compensation, which means if I'm adding something plus 169, I can add 200 and take away 31. That kind of really deep number sense that you're actually applying, you never need an algorithm. And even if they can do it with 2-digit numbers, when they get to stage 3, they're going to be able to start to add and subtract decimals, because it's the exact same thinking. We're just bridging to place values, and the place value might be bridging from 1 to tens, or it might be bridging from hundredths to tenths. It's the exact same understanding. We start teaching multiplicative place value. So what we want is kids to start thinking multiplicatively. Now you'll see that that's taught at exactly the same time as metric length. What multiplicative place value means is if I have 1, I multiply it by 10, I get 10. I divide that by 10, I get 1. Now thinking about that multiplicatively doesn't mean that I have 10 ones. It means I've made 1 10 times bigger than it was before. And if you even say to year 1 and 2 kids, if you say show me 1 and then say show me the number that is 10 times bigger, they go like that. Now show me the number that's 10 times smaller, and they go like that. That's what division is. So if kids see multiplication multiplicatively as in I'm making a number 10 times bigger, now when I divide by 10, I'm making the number 10 times smaller. So we're not adding zeros to anything. If I want to make 1 10 times bigger, it's got to go into the column on the left, because the column on the left is 10 times bigger. Now this links to the metric system, because 1500 years ago, the Hindus invented place value, and that was only from ones. So they only had whole number place value. So they had ones times 10 is 10 times 10 is 100 and so on. So they could write really, really big numbers really easily. And then finally about 1200, the Europeans started using it. So then about 500 years ago, European and Arabic mathematicians decided to extend multiplicative place value to fractions, decided to divide 1 by 10 to get a tenth, and then divide that by 10 to get a hundredth, and so on. And then 300 years ago, the French invented the metric system. And what they did was they started with a meter, they divided it by 10 to get a tenth of a meter, which they called a decimeter. Deci means tenth in Latin. They divided the decimeter by 10 to get a hundredth of a meter. Centi means hundredth in Latin. Divided that by 10 to get a millimeter. Milli means thousandth. Now most teachers don't teach decimeters. And what a lot of teachers say is you go multiply by 10. So millimeter times 10 is a centimeter. Multiply by 100 and then multiply by 1,000 is a kilometer. It's actually all by 10. And if you teach it this way, related to multiplicative place value, starting in year 3, just multiplying and dividing by 10, and that's what the metric system does. So first of all, they just had length, then they turned the length units into squares, area, then they turned the length units into cubes, volume and capacity. For measuring volume and capacity of objects with curved surfaces, they use the same prefixes. So now we have litre. Divide a litre by 10, we have a tenth of a litre, a decilitre. Divide that by 10, we have a hundredth of a litre, a centilitre. Arabic countries and European countries measure in centilitres. So it's 75 cl instead of 750 ml. And then you divide that by 10, you get a thousandth of a litre, and so on. And then when you get to mass, it's the same. So you've got a gram divided by 10, a decigram divided by 10, a centigram divided by 10, a milligram. And you go up the other way, so you get up to kilogram. If kids start learning this in year 3, they start to see the relationship between multiplicative place value and metric measurement makes it visible, because they can see things getting 10 times shorter and 10 times longer. And they physically use their arms to show this. Multiplying and dividing single digit numbers in year 3 and 4. That's basically your tables. but it's not just your tables because it's division as well. And the same as when I said when you add and subtract, it's really important the kids are at the same level for addition and subtraction. It's the same with multiplication and division. So if you just teach tables and then, which is multiplication, and then later on teach them division, they're never going to relate them. They're never going to realize that it's exactly the same thing. So the way that I teach multiplication and division, I start with multiplication and division by 2, because that's obviously the easiest one. And we look at the distributive property because we want to wean kids off skip counting for 2 reasons. Number one, skip counting means that they're thinking of it as groups, which means that they're thinking additively, because they've got a group of 2 plus another group of 2 plus another group of 2 plus another group of 2. So that's additive thinking. And again, we want them to think multiplicatively from year 3 onwards. And that's why there's no real multiplication and division until year 3, because up until then, the kids are thinking additively. The other reason is because it's just too slow. If I wanted to do 2 times 5, I could go 2, 4, 6, 8, 10. That doesn't take long. But what if it was 2 times 65? I can't go count by 2s up to 2 times 65. So it's not an efficient strategy. An efficient strategy means it works in all situations. I don't need to learn any other strategies. And the other reason is it's additive. So what we want them to do is we want them to use the distributive property. And so you've heard of the area model and that kind of stuff. That's the distributive property. The distributive property just means, say I don't know what 2 times 6 is, but I do know what 2 times 5 is. I can partition the 6 into 5 and 1 and say 2 times 5 is 10 and 2 times 1 is 2, add them together and I get 12. Now, 2 things about that. Number one, it's a distributive property, and we want kids to know that we distributed our multiplication over addition, which means when I didn't know what 2 times 6 was, I chose an addition to distribute the 6. So I distributed the 6 over 5 plus 1. That's why it's called the distributive property. We want kids to know they're using the distributive property. We don't want to make up other names for it. We want to actually tell them it's the distributive property. The distributive property works no matter what numbers you ever want to multiply or divide. It works for division too, because if I divide by 2, I'm actually finding a half of the number. So here where it says relating it to fractions, I'm relating dividing by 2 to halving. Then when they get to year 5 and 6 and they have to multiply by a fraction, they know that when they divide by 2, they're multiplying by a half. So it all just flows. Now in year 3, I've even had kids who don't know what 2 times 2 is. So they literally go 2 times 2, they partition the 2 into 1 and 1, and they go 2 times 1 is 2, 2 times 1 is 2, which is going to be 2 plus 2, which is 4. And it works with any size numbers. So I can do 8 times 365 at year 5 level, even later on in year 4 level. I can go 8 times 300, 8 times 60, because I know about that multiplying by 10 and how digits are moving. And I can do 2 times 5. You can divide. If I was going to do 365 divided by 8, I don't need an algorithm. If I'm dividing by 8, I know that 360 is 320 plus 40. So I can partition 365 into 320 plus 45. And I already know that 320 divided by 8 is the same as 32 divided by 8 times 10. This really deep understanding of multiplying and dividing happens across year 3 and 4. So it's much deeper than just learning tables. And in the syllabus it says multiply by 2, 3, 4, 5 and 10 in year 3, and then 6, 7, 8 and 9 in year 4. That's because you don't have to learn 6, 7, 8 and 9. If you know up to 5, you can partition everything into 5. And not only that, they're not just learning tables, they're learning the inverse relationship, because they're going to learn how to multiply by 2 when they know enough multiples without too much cognitive load. They're then going to divide by 2. Then the next one I do is 4. And doubling is fine. Halving and halving doesn't always work. So again, doubling and doubling is okay, but they need to still use the distributive property, because if I'm dividing an odd number by 4, say 35 divided by 4, and I halve it and I get 1 left over, I don't know what to do with that 1. So halving and halving's not an efficient strategy. I mean, obviously I show those and I teach those, but I also teach it's not an efficient strategy because it doesn't work for division all the time, or it makes division much harder. The distributive property always works. The reason I do 4 after 2 is because it's related to 2. Then multiplying and dividing by 3. Now, of course, you've got the anchor charts up for 2 and you've got the anchor charts up for 4. So the kids who are still working on them, still investigating them, keep doing that. The kids who are ready can go on to 3. And then once the kids are ready, they go on to So basically, I would say year 4, start out with the additive stuff the first few weeks. Make that decision early of how much time and effort you're going to spend on addition and subtraction, because the kids are allowed to have an algorithm in year 4. So if you just want to switch that out and just go, okay, just algorithm and compensation, we'll keep going with the additive place value because that's really important. And then when they think their kids are ready, bring in the multiplicative place value and the metric length. It doesn't matter if they don't start that till term 2, that's fine. But again, don't forget this is end of year expectation. We're not expecting kids to be really fluent with tenths and hundredths. It's an end of year outcome, not a beginning of year. And then term 2, keep focusing on those 3 things at the same time as bringing in the multiplication and division.